Welcome to classes on organic chemistry. Today's class is on organic chemistry, basic principle and techniques. It is higher secondary first year. After a long gap, I couldn't continue the class due to some unavoidable circumstances, and from today onward, I'm going to upload the classes continuously in a regular fashion. Please subscribe the channel. Chemistry in Hand, also my new channel, Physics in Hand by me. And today's class is important only because of the fact that for the beginners of higher secondary it is also important, because very often this topic is not given much importance in the class, and people or the students like you do not get much interest on this topic. But it is a very important topic for entrance point of view, and keeping in view of the incoming joint entrance or neet or JEE or any type of competitive exam, CUT, etc. I have structured the class in a beautiful way, and I think a lots of questions very often each and every year is asked from this topic, and you please minutely follow this class. Today's class is on quantitative analysis. In my last class, that is class number 16, I discussed about qualitative analysis, means the type of the element present in the organic compound. Now, the element which are present in the organic compound, we will now calculate what is the mass percentage of the element present in the organic compound. Calculation of mass percentage of element present in organic compound is dealt with quantitative analysis. So before coming to the main point of quantitative, the calculation of the mass percentage of element present in the organic compound, let me first start some of the important facts and which are very important for you to know, that is to calculate the percentage of hydrogen and percentage of carbon. Now let me take some very simple example. An organic compound is of type compound is oxidized. That is when it is say methane, ethane, propane, butane, etc. I have just balanced it in a simple manner. I have shown you how to balance it. C x and x, y, x plus y by 4 or 2x carbon dioxide plus water. We see that it gives carbon dioxide and water. Am I right? This is the main reaction from which we will find out the percentage of hydrogen and percentage of carbon. Now, along with the hydrogen, there will be the question of water, and along with the carbon, there will be the question of carbon dioxide. And molecular mass of hydrogen, water is 18, and carbon dioxide is 44. Now, what is the formula? Very important thing you need to know is what is the formula. The percentage of hydrogen is equal to, so first to write, percentage of carbon is equal to, simple formula. You need to know the formula. This percentage of carbon equal to 12 by the atomic mass of carbon is the 12 by 44. 44 is the with carbon, the carbon dioxide is related. When we made to react the oxidation reaction of CXHX, we see that in the product the formation of carbon dioxide and water. When we need to calculate the percentage of carbon, we need carbon dioxide, and when we need to find out the percentage of hydrogen present in the organic compound supplied to you, we need water. The water is 18 and carbon dioxide is 44. So the formula of carbon dioxide, percentage of carbon dioxide is equal to 12 by 14 equal to mass of carbon dioxide formed by mass of organic substance into 100, and percentage of hydrogen is equal to 2 by 18 into mass of hydrogen water formed divided mass of organic substance supplied into 100. Now the matter will be very easily understandable from your point of view when I will just talk about with an example. Let's see the example. On combustion of this gram of an organic compound gave this gram of carbon dioxide and this gram of water, determine the percentage of carbon. Now what is the formula? Percentage of carbon is equal to Mass of carbon dioxide formed, you are given the mass of carbon dioxide formed is this much, and mass of organic substance supplied, mass of organic substance is equal to and 100 of formula to get the percentage. You simply now is percentage of hydrogen is equal to 2 by 18 equal to mass of hydrogen formed, water formed is equal to this much, and organic substance is equal to this will be of about 4 point something, I think. You calculate yourself. So this is very simple, and this is a very basic problem, very often asked in the exam. So you need to know the formula first, and everything will be given to your question, and just to place the value and you will get the desired result. Let us come to the main point, that is calculation of percentage mass of the element present in organic substance is the main motto of the quantitative analysis, and this quantitative analysis was done. What are the percentage mass of the element are to be calculated is nitrogen, halogen, chlorine, bromine, iodine, sulfur and phosphorus. Up to your scope, up to your syllabus, the percentage mass of nitrogen and halogen, chlorine, bromine, iodine and sulfur and phosphorus are very often asked in the exam to find out the percentage of nitrogen, and sometimes what is the formula of the compound which reacts in the way as demanded in the question. So now, basing upon the calculation of percentage of mass of the element present in the organic compound, we need to first find out nitrogen. So how to find out nitrogen? So the process is Dumas method, and second one is KJELDAHL method, and third one is Quries method. You just minutely follow. I think in the last NEET exam, a question was asked from KJELDAHL. So due course of time, I will explain. Very simple question was asked, and you need not to be nervous. Simply just you follow my class. I think you can answer at least any type of question asked in JEE, NEET, and also I will discuss in previously it was IEEE, and it is not at present in existing schemes of exam. So Dumas method and KJELDAHL method and Quries method. So in a very nutshell, Dumas method and KJELDAHL method, both the methods is employed for calculation of percentage of mass percentage of nitrogen, but the way of calculation or the process is different. And Quries method is for halogen, means fluorine, chlorine, bromine, and also sulfur and phosphorus. I have just specified which method is meant for calculation of what element mass percentage. Very often in the exam you are asked nitrogen percentage, mass percentage of nitrogen calculated by this method, fluorine is calculated by this method, sulfur is calculated by this method, phosphorus. Very simple question is asked. So let me first start with Dumas method. I will not go to detail, but I will explain the main key points and this will be sufficient for you to answer in the entrance, also in the class exam. So in Dumas process, nitrogen containing compound mind that I have not balanced the reaction. The main key point or reaction of the Dumas method is nitrogen containing compound, a compound, organic compound where nitrogen is mixed, elemental nitrogen alone, N, elemental nitrogen is present, and this organic compound containing nitrogen is treated with CuON. It gives carbon dioxide, water, copper and nitrogen. But sometimes oxides of nitrogen may be left out in the reaction. Oxides of nitrogen, there may be presence of oxide of nitrogen. If there is oxides of nitrogen, then this is treated with gauze copper gauze, GAUZD, and that gives you so what's happened when the nitrogen containing compound is made to react with carbon dioxide, it gives carbon dioxide, water, it is not balanced, copper and nitrogen. If there is nitrogen oxides of nitrogen is present in the reaction, then oxides of nitrogen is further treated with copper gas and it gives nitrogen plus water. Mind that elemental nitrogen, single nitrogen is converted into molecular nitrogen in the Dumas method. So here the mass of the nitrogen will be 28, not 14. 14 to the 28 molecular mass. Mind that there is the difference of KJELDAH and Dumas. In Dumas process there will be 28. I will come bit by bit. So what's happened? This mixture is placed so interesting fact of this process is that when this mixture is evolved, we get the mixture carbon dioxide, water and copper and nitrogen, and this mixture is now placed Skiff's nitrometer containing caustic solution, sodium hydroxide solutions, where all the gases absorbs, leaving behind only nitrogen. So whenever we get this nitrogen only in the Skiff's nitrometer, we will then count the volume of that nitrogen and then we will calculate the percentage of nitrogen. I will take an example and I will show you. Then during the calculation of the volume of nitrogen, we'll consider saturated temperature and pressure, and I will explain what the utility of this saturated temperature and pressure, volume of this nitrogen at saturated temperature and pressure. So this is very simple one. Let me take a very simple example to clarify the fact. Let us have an example. The question is very simple. In Dumas method, for estimation of nitrogen, this gram of an organic compound gave this ml of nitrogen collected at 300 Kelvin temperature and 715 millimeter of pressure. Calculate percentage of nitrogen in the compound. Aqueous tension at 300 Kelvin is equal to 15 mm. But the formula of percentage of nitrogen is equal to 28, nitrogen N2, 14 2 is equal to 28 into 22.40 into V by W into 100, and that V is equal to is volume, saturated temperature, at saturated temperature and pressure. Let me explain a simple thing. See, from Boyle's law, we have already known that P1 V1 by T2 equal to P naught V naught T2. Means these are the temperature, initial temperature, exit temperature after T1, the volume pressure is P1 V1 at temperature, at initial temperature P naught V naught is by T2. So if you compare this one, if we want to find out V naught, means volume at saturated temperature, then volume equal to P1 V1 T naught by P naught by T1. It is very simple calculation. So we get P1 T1 T2 is equal to T naught is equal to 270 degree Kelvin and P naught equal to 760 degree temperature. T is equal to remain the same at this temperature and at this pressure, new pressure and new volume, that is, this is the volume, this volume here, we'll put this volume here and we'll find out the initial volume at this temperature. What will be the initial volume of this temperature at STP, saturated temperature pressure? What is this volume? If you now apply the V, volume is equal to this, volume is equal to this much. No, this much will not be the volume. This will be a bit less. I think a bit less when we will calculate it. So first of all, we will calculate this volume. From here, we will find out that volume is equal to P1 B1 into 273 divided by 760 into P1, and this is that pressure is equal to 715 millimeter, and aqueous tension is equal to at 300 degree Kelvin, and aqueous tension is equal to 15 millimeter, and we need to minus this temperature from minus this pressure at this temperature. It is 300 degree Kelvin. We need to deduct this temperature from this pressure from this value. So 7155 millimeter minus aqueous tension is equal to 5 mm is equal to 700. So here we are getting 700, and that volume, this volume is equal to 50, and the temperature is already 273 and 760, and what is the new temperature? At this temperature is aqueous tension is this, so temperature is 300. So if you calculate, I think this will be 41.9. so it is not 50 ml. Now very simple way, you will just put 28 by 22400, V is equal to this much at saturated temperature and pressure, and weight means where this weight is given, and we'll get the answer. So percentage of nitrogen is equal to 28,22400 into V is equal to 41.9 divided by weight is equal to 0.3, and this is equal to 100. So percentage of nitrogen is this. This is what Dumas method. Only thing is that you need to calculate the molecular mass of nitrogen, not 14, it is 28, and the volume whatever is given, you need to find out the saturated temperature and pressure, what will be the volume. You just calculate, you find it is a bit less, and aqueous tension whatever is given from initial pressure, from the pressure 7115, you minus this one, deduct this one, and put this value, you will get this one, and put this value here, you will get the percentage of nitrogen. This is very simple Dumas method. Again, it is percentage mass calculation of nitrogen. Here, how the process, what is the method of calculation of percentage of mass of KJELDAHL, it is not the same as of Dumas. Here there are two steps. Simple thing, you minutely follow a lots of question asked in the entrance exam from KJELDAHL, and minutely follow what I tell you, minutely follow, you can answer a lot of things. The process, here the process is digestion. What is digestion? First process is nitrogen containing compound plus concentrated sulfuric acid is made to react and we will get ammonium sulfate. Now next one is distillation. Ammonium sulfate react with sodium hydroxide alkali would give sodium sulfate plus water. I have not balanced it, and ammonia, and this is the main thing, ammonia. And that ammonia, when evolves ammonia, is titrated against sulfuric acid and gives sodium sulfate again. And when if acid remain unreacted after neutralization, if there is much excess of acid is there remain in the reaction mixture, then it made to react with standard sodium hydroxide solution. So out of these two, we'll find out the amount of nitrogen in the organic compound. So how we'll find out amount of nitrogen in organic compound? In the process of example, I will explain in details. So in the exam, it is asked nitrogen containing compound is KJELDAHL method is converted to answer ammonium sulfate in presence of concentrated sulfuric acid. Now what is the process? In the second step, sodium hydroxide is made to react, we get ammonia, and from ammonia we are concerned with this nitrogen. From ammonia is titrated against sodium sulfuric acid, and excess of this one is acid, if remain in the reaction mixture, is made to react to this standard sodium hydroxide solution, and out of these two we find out nitrogen. But here the nitrogen, amount of nitrogen is single nitrogen, so it will be 14, not 28. So Dumazen KJELDAH in the calculation will now in KJELDAH will tell it is 14. So now let us take one example. One thing in the entrance exam again asked, sometimes copper sulfate is used in the reaction mixture and it is used as a catalyst in order to raise the boiling point. Am I right? Sometimes it is asked what is the function of copper sulfate in the reaction. Sometimes potassium sulfate is also used, potassium sulfate and copper sulfate. Copper sulfate is catalyst used in the reaction mixture to raise the boiling point of the reaction. See, there is a bit twist here. It is milligram, it should be gram. Mind that, minority follow. It was asked in AIEEE in Kerala PMT 2012, and there are same type of questions very often asked in the entrance exam. So you see, 29.5 milligram of an organic compound containing nitrogen was digested according to KJELDAH method and evolved ammonia. As earlier I have shown you, ammonia gas was absorbed in 20 ml of 1 molar hydrochloric acid solution. The excess acid required, I told you earlier, excess acid if remains, required 15 ml of 1 molar sodium hydroxide solution for complete neutralization. Our main target is this. Now, if excess acid is already in the reaction mixture and this excess acid was 15 ml, so what is the total volume of the acid utilized? Then excess amount of acid should be subtracted to get the amount of the acid required to neutralize ammonia to absorb. Am I right? So what's happened? NX N means normality and BX morality, volume. So that is for one acid N1B1, for base N2 B2. So to get the net acid utilized in the absorptions of ammonia, acid left was 15 ml sodium. Acid left was required to neutralize 1 molar sodium hydroxide for complete neutralization. So what is the volume of that acid? Equal to NV 20 into 0.1, and if I subtract the base 15 into this, 15 into, what you get here is 2 minus 1.5 is equal to 0.5. Am I right? So this is the exact amount of the volume required for neutralizations of ammonia or absorption of ammonia by hydrochloric acid. Now what is the formula? Percentage of nitrogen is equal to 1.4 into NX BX divided by W. This is the formula. Now what we get here is 1.4 into NX BX equal to 0.5, and what is the amount of the substance used is equal to 29.5 milligram, and if we convert it into gram, then this will be equal to this into 1000 will go up, and this will be in gram. So very simple, nothing tough. You don't take any other method to do this one. It will take a lot of time. To save the time, you find out the actual volume of the acid. So acid, excess amount of alkali required to neutralize the excess acid should be subtracted from the original acid. So NBX NXBX of acid should be is this, and base alkali is this. So we are getting 0.5, and that if we put this value here, we will get percentage of nitrogen is 23.7. Very simple. In Quries method, what's happened? Organic compound containing, it is meant for chlorine, bromine, iodine, sulfur and phosphorus. Am I right? So what's happened? The first Quries method, what we do here is organic compound is made to react, organic compound either containing chlorine or containing bromine or containing iodine, when made to react with fuming concentrated fuming nitric acid in presence of silver nitrate, we get silver halide. If it is chlorine, silver chloride. If it is bromine, silver bromide. If it is iodine in the present in the organic compound, silver iodide. And from this we will calculate the percentage of chlorine. Percentage of chlorine will be equal to 35.5. You should learn this by heart. Very simple. I will take one example and I will tell. Percentage of chlorine is 35/5, and this is molecular mass of the compound AgCl form. It is fixed 143.5. We needed to calculate. And if it is silver bromide, it is 188. If it is silver iodide, it is 235. And the atomic mass mass of chlorine equal to 35.5, and chlorine equal to 80, and iodine equal to 127. It is known to you all, and you just put the value. And here amount of AgCl bromide, Ag bromide, Agi formed will be given in this question, and this will be here, and the what is the organic substance taken will be also given to you, put here, and you just do the sum. Very easily you find the answer. So this is all about of the Quries method of calculating chlorine, bromine and iodine. Now sulfur. For estimation of sulfur, mass percentage of sulfur, organic compound containing sulfur plus nitric acid, sulfur dioxide gives you sulfuric acid, again I have not balanced it. So sometimes in the exam it is asked, when you are asked to find out the estimate percentage mass of sulfur, what is formed when the sulfur containing compound is made to react with nitric acid. Answer is sulfuric acid. And then sulfuric acid we mix some barium chloride. This gives you barium sulfate and hydrochloric acid. So from again it is very simple. You just learn the formula, and if you don't learn, you will forget this one. You write the mass of sulfur is 322, and barium sulfate, when we have used this barium sulfate, and the mass of barium sulfate will be, if you calculate, it will find 233, and the mass of the barium sulfate formed will be supplied in the exam in the question, and mass of the organic substance supplied to you also will be given in the question. And just to give 100, multiply 100, you will get the answer. I will take the practical answer question, and I will explain this a bit later. Now again, process of estimation of phosphorus. by Quries method. Here we are not a question may come in our mind that where from this all this we got. We have used magnesium sulfate, ammonium hydroxide, ammonium chloride, and organic compound containing phosphorus, and that gives you magnesium ammonium sulfate, magnesium pyrophosphate, and from this magnesium pyrophosphate we can very easily calculate the mass percentage of phosphorus. Am I right? So this is all about the percentage mass calculation, that is quantitative analysis. Some of the more important example, and let me solve this question of entrance exam so that you will get the idea what type of questions very often asked in the estimations of nitrogen present in organic compound by KJELDAH method. The ammonia gas evolved from this gram of compound in the estimation of nitrogen is neutralized 10 ml of 1 molar sulfuric acid. This is the point. In the estimation, in the very beginning I told you ammonia gas is evolved. Am I right? In the titration process, in the distillation process, ammonia is evolved, and that ammonia is made to react, is neutralized by 10 ml of 1 molar sulfuric acid. Now our target is this 10 ml of 1 molar sulfuric acid. So 10 ml of 1 molar sulfuric acid is nothing but equal to 20 ml of 1 molar ammonia solution. Why? Because it is dibasic. 2 proton is there. If dibasic acid is there, so the amount of volume of the dibasic acid will neutralize double of the base. So here base is not given. So from the concept we have taken, because from this we will find out amount of nitrogen. So you are given the nitrogen which evolved was neutralized by 10 ml of 1 molar sulfuric acid. So we need to calculate that 10 ml of 1 molar sulfuric acid will neutralize 20 ml of ammonia because it is dimolar. So from this we have got 20 ml of ammonia from the concept, and from this we will calculate the percentage of this. This is a reference one. From this reference we will calculate. So what is 1 molar? What is 1 molar? 1 molar means 1000 ml. 1 molar means, it is normal concept, 1000 ml of 1 molar ammonia will give nitrogen equal to 1 nitrogen equal to 14 gram. Am I right? So therefore, how much ml? 10 ml. Sorry, 20 ml. So 20 ml of 1 molar ammonia is equal to 14 by 1000 into 20 gram. Am I right? So now what is percentage? Percentage of nitrogen is equal to 1.4 What is the initial amount of organic compound given? That amount will be below. And what is the calculated amount of ammonia is above. This is the amount supplied and this is produced. So this amount 14100 into 20, this is some amount, and that amount is produced from this, and that is equal to into 100. This is the percentage, and you will calculate the percentage of 56%. You calculate yourself, you will find. Here the point is that, say this is X. This X amount has evolved from supplied amount. This X amount has evolved from supplied amount, and percentage is 100. So that I have placed here, and promptly I have done it 54%. So this is one of the important question very often asked in the entrance exam. This is another question from KJELDAH process. Sir, ammonia evolved from the treatment of this amount of an organic compound. For estimation of nitrogen in 100 ml of 1 molar sulfuric acid, the excess of acid required 20 ml of 0.5 molar solution of sodium hydroxide acid. Now we need to, this is the reference. From this reference we must come to the amount of ammonia required to be neutralized by this amount. So 100 ml of 0.1 molar H2SO4 is equal to 200 ml of 0.1 molar ammonia. Am I right? So we have got this amount of ammonia. So now this is reference, this part is not required in the solution. So what is NXBX? NXBX is equal to, first 200 equal to 0.1 minus 100 into 0.1, so that is equal to 10. So percentage of nitrogen is equal to 1.4 NXBX divided by W. 1.4 NXBX is equal to 10 and W is equal to 3, and we will get 46.6%. Now you are asked, what is the compound, organic compound from where nitrogen is evolved? What is the compound? So organic compound containing nitrogen must be a compound where the percentage of nitrogen is 46.6, and it is in the option, it is given, it is urea. It is urea. The compound is urea. Answer, compound is urea. Urea, compound is urea. Now you may tell how. Let me tell how. You see, 46.6% nitrogen is only present in urea. How? Because molecular mass of this urea is equal to 60 gram. Urea contain nitrogen how much? 2 nitrogen. Nitrogen 14, 28. Therefore 1 gram contain 60 into 28. Therefore percentage of 100 gram is 60 into 28 into 100, and you will get, after calculation, it is 46.6%. So percentage of nitrogen in urea is equal to 46.46%. Since we have calculated from the given data of the mathematics that nitrogen percentage is 46.6, hence the organic compound must be NH2CO NH2. This is all about the today's class, and in the next class I will invariably explain empirical and molecular formula, very often asked in the exam. Kindly subscribe the channel to get most recent and new solution which will be tremendously helpful in upcoming entrance exam. Thanks a lot for watching the class.